Okay, so let's start today's sessions. I hope all of you enjoyed the previous session. This session will focus on exploratory data analysis, EDA, and visual EDA. This session will be taken up by Amara Pranav and Karthik. So I'll hand it over directly to you guys, and I hope all of you enjoy this session. If you have any doubts, do tell us in the chat or unmute and ask, or you can put up in the group.
Good evening, everyone. Am I audible?
Yes.
Yeah. Can everyone see the screen? Hello?
Yes.
Yes, Karthik, it's visible.
Yeah, okay. Now, let's dive into EDA, Exploratory Data Analysis. EDA is a crucial step in understanding any dataset before applying machine learning or statistical models. Let's think of EDA as checking out a new playlist before playing it at a party. You don't just hit play blindly. You can scan the songs, see what fits the vibe, remove the ones that don't, maybe even spot patterns in which what sounds good together. Similarly, in EDA, we analyze, visualize, and clean the data to uncover patterns, trends, outliers, and relationships between variables. But why is this important? Because bad data leads to bad models. EDA helps us detect errors, missing values, and hidden insights that can shape better decisions. Now let's move on to mean, median, and mode. We'll just cover up the basics. Basically, mean is the sum of values, all the values by the total number of values, and median is the middle value when the order is sorted. And mode is the value that repeats most frequently. There are two types of mode. The first one is a uni mode, and the second one is a bi mode. In the first example, you can see 3 repeated 2 times, so we get mode as 3. But in the second case, we have 3 and 7 repeated twice. This is called a bimode, where we have two values. But let's go into real life applications. Mean. Suppose you and your 4 friends are eating at a fancy restaurant, and the total bill was 500. Instead of debating who ordered what, you split the bill evenly. Everyone pays 100 rupees, $100, even if the guy only had a salad. But what's the problem here is, for suppose let's take a group of college people. Let's ask them about their bank balance. We can say that their bank balance will be in some thousands. But what if we add Elon Musk into the group, and then the median shoots into millions, even though most of them have only thousands in their bank accounts. So in this type of scenarios, mean is not always the best metric because Elon Musk here is an outlier, and outliers distort reality. Well, what can we do? We can use median. Let's take another example. You line up 5 people based on their height, as given in the PPT, and the median height is 5'8". If we add Shaq into the group, like we did Elon Musk in the previous example, it doesn't change anything. The median is still 5. The median doesn't change very largely, like we went from thousands to millions in the previous example. Unlike mean, median isn't fooled by outliers. Mode. Where do we use mode? Mode is about popularity and patterns. Most it is used mostly in retailers and marketers. For example, you have a closet and you own 10 black t-shirts and 3 white, 2 blue. Black is the mode here. In business, for Nike, if Nike sees 70% sales in Air Force One, they don't care about the average shoe size or mean or anything. What they care about is how many number of Air, Air Force they are producing. This is most applicable in retails and marketers. Well, now we know why do we find mean, median, and mode. When the data is balanced and smooth, and there are no outliers like Elon Musk or Shaq in the data, we can use mean. But when there are outliers present in data, it's best to use median. And mode is used for marketing and business decisions. Now let's go into variance and standard deviation. The basic definitions are variance measures how spread the numbers are from the mean, and standard deviation is the square root of variance. It tells us how much the data deviates in the same units as the data. Let's understand with okay. Let's understand it with a code. No, with an paper example. As you can see, we take an let's take an example dataset, exam scores. Here we have exam scores of 5 people. And the first step is to calculate the mean. Here the mean is 83.8. And the second step we do is to calculate the difference, deviation from the mean. What we do here is we take individual score and subtract it with the mean. Here we get minus 5.8 as the deviation for 78 and 1.2 for 85. But since there are negative and positive values, we do we square the deviation and finally add the square of the deviations. And then now we calculate the variance. There are two types of variance. The first one being a population variance and the second one is a sample variance. Population variance is used when we have the complete data set. And sample variance is used when we only have a sample of the original data set. For suppose, we use population variance if we have the scores of all the people in the classroom, and sample variance only if we have half of them scores. And the formula for population variance is sum of squared deviations by n, which where we get 36.16, and for sample variance, it's sum of squared deviations by n minus 1, where the answer is 45.2. Now we calculated the variance. Now let's calculate standard deviation. For standard deviation, what we do is we take the square root of the variance. It's simple, right? For population standard deviation, it's the square root of population variance, which is 6.01, and same goes for sample standard deviation. But why do we need to calculate this? Hello? Yeah, a higher standard deviation means more spread, and the lower standard deviation means the values are closer to the mean. Now we understood how to calculate it with pen and paper. Now let's go to the code. Does anybody have doubts until now? Okay, let's go to the coding part. First, we import all the necessary libraries and then load the dataset. Here, this is an inbuilt function where we can use dot head to take the top 5 rows of a dataset. First, we need to take a numerical column. As we can see from the given dataset, energy consumption is one of the numerical columns, and I am taking that as my uh, data. And then what we do is we drop all the null values for the numerical calculations, and then we find the central tendency. We can see that mean value is equal to np.mean of data, which is an inbuilt function where we used to use for finding mean, and same goes for median and mode. Here in the mode we use ilog 0 because as we talked about, this is a binary mode where we have multiple modes. So we will take the first mode, the most repeated value, and we can see we have mean as 4066 and median as 4175 and the mode as 1683. And how do we calculate standard deviation and variance? We can use the inbuilt functions np.std, which calculates the standard deviation, and np.vr of data, which calculates the variance. Does anybody have any doubts up until now? Until this topic? Okay, I'm going to the next one. Now let's understand interquartile range. What is interquartile range? It's like the middle chunk of the data where most of the normal values sit without extreme ones. Like imagine you have a group of friends and the money they have in their wallets are the following: 150, 200, 300, 500, 700, 1000, 1500, 2000, and 2500, and so on. But how do you calculate interquartile range? Well, the first quartile is the 25th percentile, where the value below which 25% of the data falls, and the third quartile is the 75th percentile, where the value below 75% of the data falls. Well, the formula for IRQ is Q3 minus Q1. This gives us the range of the middle 50% of the data set. For the example, the Q1 is 300 and the Q3 is 2500. So the middle 50% of our friends have between 300 to 2500 in their wallets. But one rich guy suddenly has 10,000 in his bank accounts. Now we need to check if this guy is an outlier or not. To spot outliers, we use a formula, which is we find the minimum and maximum of our range. To find the minimum, we use Q1 minus 1.5 into IQR, which is minus 3000, which is our minimum. And to find the maximum, we use the same formula Q3 plus 1.5 into IQR, which we get 5800 as the maximum. If a person is below or above these two values, he is considered an outlier. Here our friend has 10,000, so he is way above 5800, so he is an outlier. Why do we use this? Because as we know, outliers distort reality, and from this we can eliminate outliers. And now the coding part. Here Here we use normal NP percentile of data, comma 25, which is the Q1, and the median is the Q2, and the Q3, this which is the 75th percentile. Q3 is the 75th percentile, and Q1 is 25th percentile. Now we got our Q1, Q2, and Q3. Now let's see skewness and kurtos. Skewness. What it tells is basically if the data is symmetric or leaning to one side. There are three types of skewness: left skewed, bell curve, and right skewed. Left skew is also known as negative skew, where the mean is less than median, and less than mode. And if all three values are equal, which is a symmetric distribution, we have bell curve. And right skewed, where the mean is greater than median and greater than mode. And we use an inbuilt function skew of data. But why do we need to find the skewness? Because as we talked about, skewness tells us about whether we should use median or mode. If the data is symmetric, no skew, we can use mean. There are no outliers present. But if the data is skewed, that means outliers are present, and median is the best option here. Coming to Kritos. Kritos measures which data has heavy or light tail compared to normal distribution. And there are mainly three types of Kritos. The first one is a leptocritic, second one mesocritic, and third one platycritic. The leptocritic is a high Kritos, where the normal distribution with balanced tails. Here you can see the positive Kritos has a leptocritic, which means there are more outliers and heavier tails. And the low kurtosis means fewer outliers and lighter tails. But why do we need to find this? Because we can see whether if we get an leptocritic, we know that we have more outliers. And if we get a low platycritic, we have few outliers or lighter tails. And if we get a mesocritic, the distribution is normal. Now, types of EDA. There are three types of EDA: univariant analysis, bivariant analysis, and multivariant analysis. Univariate analysis is used when the data consists of one type of variables, for example, histograms. And bivariant analysis is when the data consists two types of variables, example, scatter plot. Multivariant analysis is when data consists three or more variables, for example, cluster analysis. Now let's see one of the plot. Now let's see box plot or box and whiskers plot. Before, as we discussed, we know how to find IQR, interquartile range. It helps us here because in box plot, we can see the visual representation of IQR, where Q1 is near the min and Q3 is near the max. And anything which goes like in the previous example, the guy with who has 10,000 in his bank account is an outlier, which is above the max. And here, as we can see, the box between Q3 and Q1 is interquartile range. And the median here is Q2, which separates the box into two halves. Coming to the code, here. Here, figure figure gives us a blank canvas, and the figure size 6,4 gives us 6 inches wide and 4 inches tall blank canvas. And as I, and I selected energy consumption column and colored it orange, as we can see here. And as we talked before, in box we have three types of skewed. Left skewed, which means the mean is less than median, because the mean is pulled by the left by the outliers. For example, if a student has more students has high score and a few students score very low. And right skewed, where the mean is greater than the median because it is pulled by the outliers. For example, a salary in company where most people earn between 30K to 50K, but a few executives earn millions. And coming to scatter plot, we can see six different scatter plots here. The first one is a correlation scatter plot the x where the x increases because they both are positive correlated. As x increases, y also increases. And the second one is a negative correlation plot. As x increases, the y decreases. And the third one, as we can see, there is no relation between x-axis and y-axis. And down in the clustered data, we can see that there are two types of two types, different cluster 1 and cluster 2. This happens mostly in shopping, where we can see one category buys the expensive products and the other category buys the budget items. And the outliers here, which where we can see most of the majority go in a same range, but there are some outliers in this red color who are way outside their range. And in dense data points, as we can see in the third scatter plot, this one population in a city is an example for this kind of plot, where we can see some places have most population and other doesn't have most of the population. Now, yeah, here I took building types. Here I'm comparing energy consumption and square footage. Scatter plot is used for correlation. We can see this is a positive scatter plot, where as the number of square footage increases, energy consumption also increases. Here the blue dots represent the residential building types, and the white ones represent commercial building types, and the orange ones represent industrial building types. And coming to the code, as we can see below, the plt.figure gives us a blank canvas which hides about 6,4 dimensions. And I took square footage for the x-axis and energy consumption for the y-axis. And plt.title gives us the title as we can see here, and X label is square footage, Y label is energy consumption, and pl.show gives us the graph. Hello, am I audible?
Yes, you're audible, Karthik.
Yeah. And now Pranav will continue.
Karthik, can you continue presenting the PPT? I'll just.
Yeah, okay, sure.
So I'll be starting off explanation with the graphs, various types of graphs for analysis, as well as understanding them and how we code them. So we'll start off with an histogram. I think most of you will know what a histogram or a bar graph is, correct? Hello? Guys, please
Yes.
respond. Yeah. So can anyone explain me what a bar graph or an histogram is? And what is the difference between a bar graph and a histogram? Yeah, Shravya. Yes. Pavni. Anyone? Hello. Hello. Okay, so if you guys are not answering by yourself, I'll be calling out names for you to answer. Is there any volunteer? Okay, so Arushi Sharma, leaving. Okay. Harsha, Bandi Harsha. Okay, cool. So I'll tell it myself. So for continuous data to represent and to see which one has higher counts, we use a histogram. While for discontinuous data or unique values, categorical values, we use bar graph. Karthik, can you move to the next slide? Yeah. So here you can see unique values, suppose 2016, 2017, 2018, and so on. Generally, you can keep if number of cats are 80, number of dogs are 70. These are separate values. Generally, for these kind of things, we use bar graphs. Well, for continuous values, we use histogram. Okay, so moving on to next, Karthik. KDA plot. What do you think is a KDA plot? Looking at this, what do you feel? Anyone? Guys, anyone reply? Abhishek Pandey, Rochit, can you hear me?
Yes, you're audible, Pranav.
Okay, okay. So So KDE plot. What is a KDE plot? It's a smooth representation of an histogram. So it's something similar to histogram where the points are connected using a single line. That's a KDE plot. Yes, moving on to next. Karthik.
Yeah,
Yeah.
change.
Yeah. So this is a line plot where the points are connected using lines to show trends over time. Suppose the time is fixed and time is an independent axis. Over time, how the entity is changing, either it's increasing or decreasing. To find out that, we use line plots. It is generally used in stock market. If anyone of you do some trading, you will be seeing this line graphs, line plots in that. Okay. Karthik, next. Pair plot. What do you think is a pair plot? Pair plot creates a grid of scatter plots for multiple numerical variables. So for multiple variables, if you want to see how the correlation is, to find how they're changing together or understanding the interactions between these variables, we use pair plots. It is generally used for feature selection kind of things in machine learning. Yeah, I'll be presenting the code. Karthik, stop it. Yes. Can you see my screen? Hello.
Yes, Pranav, we can see your screen.
Okay. Guys, it would be great if any of you volunteer to answer. All silent. Okay. So, okay, let us go through bar graph. Generally, it's very easy to build a bar graph, but I just wanted to show you all the parameters that are included within the bar graph. So I just made it complex just to make it easy for you to understand all the types on how you, what if you change, what is going to change. So as you can see, I have chosen the building type from the dataset for displaying the bar graph. So within that, to display the bar graph, these are all the parameters that I've been using. So for x-axis, I've used building underscore types. So from here, building underscore type, what do you see? Residential, commercial, industrial, residential, and so on. Correct. So there are three types. So these three types, the counts of each, I wanted to plot in the bar graph. For which, what I did is y-axis, I named it as counts. So it directly takes the counts. This is an inbuilt function that directly gets the count variable and then it displays in the bar graph. And I've set the width as 0.6. That is the width between each, for each graph. And the color, edge color is the end part that you can see here. And the line width, this is alpha. This is the transparency level, which you can increase and decrease and play around with. Then this is the line style. Alignment is here. As you can see, it's towards the center. You can move it. And then this is for hatch pattern. And then first what you do is you'll give the title along with the font weight and the color. And then you'll give the X label, whatever you want to be the label in the X axis. Here it's building type. So you gave it as X label, and Y label is count, which is the Y axis label. And then X ticks is the rotation of the x-axis labels. So you can see here commercial, industrial, residential, right? These three are oriented to 45 degree. So here you have set the rotation to 45 degree and set the font size to 10, which again you can change. And y-tix is 10. So there is no rotation here. So it's all straight. And this is the line style, double dash alpha. Uh, okay, moving on to histogram. This also has similar parameters. If none of you are answering, then I'll skip through it. I won't go in much detail for. Any volunteer? No one is interested? Hello?
Guys, your seniors and your classmates have worked very hard for writing these codes, making PPTs, preparing for this session. I hope you answer it and appreciate what they're doing. It's for your benefit.
Okay, so anyone ready to answer?
Pranav, can you repeat the question?
Uh, okay. Firstly, what do you think is the difference between a bar graph and a histogram?
Histogram is used for continuous values and bar graphs is like used for discrete values.
Correct. So, what do you think changing this parameter rotation equal to 45 to rotation equal to 60 do? Here there is a rotation parameter, correct, for x ticks.
Like for hatching.
Okay, so it is for this x labels, whatever x labels are there. This is currently in the orientation of 45. So suppose I change it to 60, then this orientation will become more. I'll just change and show. Yeah. So, see, can you see the orientation has increased?
Yes,
Now,
yes.
suppose we keep it, we can change that, and this color is for the color of what is written here, and this is for y-ticks. Here there is no rotation parameter added. Suppose we add, then even the y parameters also will have a tilt. And then this is the line style and alpha parameter. So these are the parameters for plotting an histogram. So for plotting a histogram, um, I have chosen the square footage thing from the data set. So this is our head, right? So this is the square footage. So how much square feet the houses are for each type of the building. Yeah, so this is the frequency, this is the square footage, how these two are interrelated. We find that. Mm, so if we change the sky blue to blue, what happens here? The color parameter.
The color of that bars will change into a more darker shade of blue.
Yes. Okay, good. So we'll move on to the next graphs. Uh, KD plot. Uh, can you explain me what a KD plot is? Looking at the diagram, what do you feel about it?
Smooth representation of an histogram.
Yeah.
Smooth representation of histogram.
Yeah, correct.
Single line connecting all the points.
Yeah, correct. So KD plot is nothing but the smooth representation of histogram. That's correct. So what we did here is we chose an x-axis, we chose the x-axis and energy consumption and y-axis as the density, and both of them we plot together. After we plot, these are all the parameters that we set here. So the color, the line style, line width, and all these things. So once we have plotted, we get what is the interrelation between the energy consumption and density. So we know at what energy consumption the density is highest. So energy consumption equal to 4000, the density becomes the greatest. Then going to line plot. Um, why do you think we use a line plot?
We use it
To
over
see the
time
trend,
To see the
trends and all, stock market and everything.
yes, to see the trend on how these two are interrelatedly changing together, if they're increasing, if they're decreasing, and to know whatever is the relationship. So for that, this is the code for the line graph. So normally you can just write this. This will build you the line graph, but I've done this code just to show all the parameters again. So the marker type, the line style, the color, marker size, all these can again be edited, and with that, the way you look at the graph gets changed. Moving on to next. So this is a pair plot. For pair plot, we have not made use of the original matplotlib. Here we have made use of the SNS. SNS is nothing but Seaborn. This is another inbuilt library for doing plots. So here, whatever we have chosen: square footage, number of occupants, energy consumption, building type, building, and the hue is also building type. This is a palette type Hazel. There are multiple palette types which we can use for pair plot. So from this we get to know the relationship. Uh, so we consider pink as residential, green as commercial, and blue as industrial. So we know how these three are changing in square footage. So you can see that the pink comes to the left side and green is somewhere in the between, then blue is somewhere towards the end. So all three have a different square footage. Uh, so from this, what you understand is industrial spaces are larger compared to residential spaces, and commercial spaces are somewhere in between. Even the number of occupants is somewhat similar. From this, we can see that in the left side, we can see more of the residential. In between, we can see more of commercial, and in the right, we can see more of industrial. So wherever there is industrial, there are more occupants. And likewise for the energy consumption, again, you can see the same thing that for industrial, it's higher. So from this what you get is again to know the relationship between each building type to the energy consumption. So the color is also changing based on the categorical value, that is the building type. With that, you are getting the relationship. Then moving on to heat map. I think Karthik has explained heat map. Did everyone understand what a heat map is?
No, I didn't.
Okay, okay, you didn't. Okay. So heat map. What is a heat map? Heat map is to know which one has higher and which one has lower in correlation. So suppose we consider two features, which two features have higher correlation and which two features have lower correlation. Suppose we consider square footage and number of occupants, and both of these are changing a lot with respect to each other. Suppose number of occupants is always increasing with the building size, that is the square footage, then these two are strongly correlated. If it's always either both are increasing or both are decreasing, then both are strongly correlated. But if there is no relation between these two and both act independently, then the correlation coefficient is very low. So we take the correlation coefficient between 0 and 1, and then we generate the heat map, which looks like this. So here we can say that we are taking 5 features and we are seeing the correlation with the rest of the features from each feature. Suppose square footage is strongly correlated to square footage, obviously, because it's the same feature. Either both will increase or both will decrease, the same thing will happen. But it's less correlated with number of occupants. So it's not correlated at all. It's almost 0.03. But it's strongly correlated to energy consumption. So if the square footage is high, it means the energy consumption is also higher. So all you get to know is the correlation between the features using the heat map. Any questions?
I have a question.
Yes.
Why are there negative values in the heat map?
So there can be a negative correlation between two features. Suppose I can say that suppose this is increasing, the other one is decreasing, or this correlation coefficient can always range between +1 to -1. So you see the similarity between these two. The strongest correlation is always +1, and the weakest correlation will be equal to -1. That is, we can say that both are completely independent, or both are not correlated at all when it is equal to -1. It generally never goes till -1, but it will remain in the lower values of the negative where the correlation changes. Yes. Okay, then did that answer your question, or you have any other doubt?
No, it answered my question. Thank you.
Okay. So moving on to clustering. Um, did you guys learn what a clustering is? Does anyone know what clustering means? Hello?
It's associated to the multivariate type of.
Not really. Okay, so clustering is nothing but dividing a group of dividing data into several groups. So suppose I have random data, and I have to split this data into several groups. So suppose I have class animals. So animals is my data, and this, how will you cluster? You will cluster dogs, cats, and so on, right? So different categories. So what we have predicted here is, what we have done here is cluster analysis. That's basically for hierarchical clustering. So what happens is, first it will divide it into the smallest subclass, and then combines similar subclasses, then again combines these bigger subclasses, and then combines everything to a single class, that is the biggest class, which we have chosen here as animals. So to analyze on how this is happening, we make use of this to know where exactly it's getting combined. So suppose uh, we can have a subclass called reptiles, called mammals, and so on, and then again these all together combine into animals. So this is the broader classification. So that is clustering. So what cluster analysis does is helps you know in which point exactly these are getting combined. Any questions? Hello? Hello? Guys, everyone understood?
Yes.
Yes, sir.
Cool. Yeah, I think that covers. Abhinav, you have anything to add on?
No, it was a good session, guys. So I hope all of you enjoyed it. Today, by the end of the day, we'll post the assignment. So in the assignment, just one instruction that we'll be forwarding some data sets. You can choose any one of those, or you can choose any one you want from the open data sets given in Kaggle or any other website. And you can attach that data set with your assignment. So when we are checking, we can refer and check it out. Okay. I think that will be all. Any questions from your end? Also, guys, we have posted the feedback for the previous week's assignment, so you can check it out. And if you have any doubt regarding that, please reach out. Anyone wants to add anything, any questions?
So the PowerPoint PPTs that you've used for this lecture, will it be available?
Yes,
The
we'll post that on our website. We'll again put up the link in
Okay.
group so you can access that. Okay.
Thank you, sir.
Okay, then anything else anyone wants to ask?